Okay, great. All right, well, thank you for coming back today. That means that either I did a good job or you're crazy, or maybe a combination of the two, but we're going to continue on. We have a lot more slides. In fact, there's more slides to cover today than there were yesterday, but yet we have less time today than we did yesterday. So I'm going to have to try to speed through them. There will be a lot of things that are just something for you to know or to memorize. It's not really something to necessarily understand. So hopefully with those, be able to just hit the slide, hit the answer, and move on. If it's something complicated or something that really needs to be explained, I will definitely explain it. And of course, if you have any questions about something afterwards, you can always send me an email. So please feel comfortable reaching out to me, and I will help answer anything, including what kind of radio should I buy or something like that. I will be glad to tell you. So with that, we'll go ahead and get started. So the question is, which of these following devices is used to provide data to the transmitter when sending automatic position reports from a mobile amateur radio station? The answer is a GPS. So obviously, if it's talking about automatic position, GPS would tell you where your position is, such as your location. Okay. So the question, so what does the abbreviation PSK mean? PSK is phase shift keying. This is just something that you have to memorize. PSK, phase shift keying. What name is given to an amateur radio station that's used to connect another amateur radio station to the internet? And the answer is gateway. So a gateway connects one station to the internet. What is the Internet Radio Linking Project, IRLP? And it's a technique to connect amateur radio systems such as repeaters via the internet using voice over IP. Again, these are all things that you just have to know. There's not really an explanation beyond that. It's just understand what that technology is. What type of tones are used to control repeaters linked via IRLP? Don't get confused, and don't think that CTCSS, we talked about those repeater tones. Those are the tones that allow you to access the repeater, to break its squelch. This for using IRLP, this is the DTMF. DTMF are also known as the touch tones. So the same tones that are on the, on a telephone that are on the front of your radio. And so if you were dialing in a phone number, you're dialing in a remote repeater using IRLP, you would use the DTMF tones on the keypad on the front of your radio. How is access to some IRLP nodes accomplished? And it's by using DTMF tones. So really the same similar question as the one before it. What is meant by voice over internet protocol as used in amateur radio? And it's a method of delivering voice communications over the internet using digital techniques. So it's basically digitized voice sent over the internet. What must be done before you may use the Echolink system to communicate using a repeater? And the answer is you must register your call sign and provide proof of license. So the Echolink system is just another internet linking system between amateur radio systems. One unique difference to it is Echolink can actually just be run on a laptop. And so you could use your laptop and connect to a repeater system. And that's why they want you to have proof of license so that just not anybody can get on there. How might you obtain a list of active nodes that use voice over IP? Well, all the above are correct, so you can subscribe to an online service from online repeater from online repeater lists that are maintained by local repeater frequency coordinators or from a repeater directory. This would be a list of active nodes that use voice over IP. So if you said, oh, well, that IRLP or Echolink sounds interesting, I'd like to know how to use that. Well, then you would go online and find out what local repeaters participate in that. What type of transmission is indicated by the term NTSC? And it's analog fast scan color TV signal. There's nothing about that except knowing what that is. I don't know. I don't know offhand. I do know NTSC is used in North America and PAL is used in Europe. And now they're pretty much not used at all because analog TV is gone, except amateur radio still utilizes that. Okay, National Television System Committee. What is the typical bandwidth of an analog fast scan TV transmission on the 70 centimeter band? The answer is about 6 megahertz. So it's a very wide signal. What they're talking about with fast scan TV, just so you know, it is you would have a video camera connected to a device that then would connect to your radio, and you would actually broadcast your picture over the radio and be able to, somebody else on the receiving end would see you, and then when you stop transmitting, you flip it off and then they turn theirs on and you would see them. And it's basically like a video conference. Now, it seems commonplace over the internet now, but ham radio has been able to do this for over 40 years. So it was obviously very relevant then. It's maybe less so now, but it is still something you could choose to do and something that people are doing. Okay, what is a transceiver? So a transceiver is the combining the functions of a transmitter and receiver. Back in the old days, they used to have separate transmitters and separate receivers. Now everything is combined. Which type of voice mode is most often used for long distance, weak signal contacts on the VHF and UHF bands? And it's single sideband. Anytime you see single sideband, you should be thinking it's weak signal. That's the key there. What is an advantage of single sideband over FM for voice transmissions? The answer is single sideband signals have narrower bandwidth. So FM takes up a lot of frequency space. Single sideband is very narrow. Single sideband does not sound nearly as good as FM, but you can fit more single sideband conversations in a given frequency range. What is the function of the single sideband CW FM switch on a VHF power amplifier? And it sets the amplifier for the proper operation in the selected mode. So this is just simply saying that you will, if you have a power amplifier, it can usually amplify single sideband and Morse code or FM. And so you simply need to select whichever mode you're going to use on your radio. Which of the following is a form of amplitude modulation? And the answer is single sideband. The way that works, so if you have an AM signal, okay, you have the center line, which is your carrier, and then you would have your voice signal here. And this would be your upper sideband. This would be your lower sideband. And that's because this is above the carrier. This is below the carrier. And put the carrier here. Okay. This makes up an AM signal. In order, you can understand that the carrier consumes some amount of space. The upper sideband consumes another amount of space, and the lower sideband consumes yet another amount of space. There's three components there. In order to reduce the amount of bandwidth so that you can go to a single sideband, you simply just eliminate the carrier and one of those sidebands, either the upper or the lower, and therefore it's single sideband. Okay, there's nothing more complicated than that. It's just, however, if you eliminate one of these sidebands, and every time you try to shrink down the signal to make it more efficient, you lose audio quality. So that's your trade-off. So that might be why, well, why doesn't everybody just do that? Well, because sometimes it's better to have a higher quality sounding signal. And certainly, as you know, from the AM radio in your car going to FM stereo in your car, FM sounds certainly much better. And that takes up a lot more bandwidth. Yes.
So single sideband is cut down all the time?
Yes.
So it was a FM wave?
No, it was an AM. Yeah. And further reduced. So yeah, that AM transmission would have had a carrier, the lower sideband and the upper sideband, and they would have eliminated the carrier and one of those sidebands. Correct. They just don't incorporate that within the modulation of the signal. Which sideband is normally used for 10-meter HF, VHF, and UHF single sideband communications? It's upper sideband. Why? Because it is. Remember, this is like the gentleman's agreement. We're going to use upper sideband here, and we'll use lower sideband elsewhere. That's why it is. So you just need to know that. There's no trick or rhyme or reason. It's just because that's what was agreed upon. Which of the following describes combining speech with an RF carrier? The answer is modulation. Okay. So this would be the modulation, which is what's contained within those sidebands. That's the actual part that you hear and understand. And as I said, if you eliminate one of those, you're eliminating one of the paths of information. So therefore, the quality of the signal must be reduced, but the amount of space it takes is also reduced. But this is the modulation. No, the amount of space refers to the amount of bandwidth that's consumed. Yeah. And bandwidth would be measured from frequency A to frequency B. That's, yeah. What is the approximate bandwidth of a single sideband voice signal? The answer is 3 kilohertz. Which of the following is an appropriate receive filter bandwidth for minimizing noise and interference for single sideband? What this is talking about so I have a single sideband signal. And from here to here is 3 kilohertz. Okay. My signal is contained within that. Okay. But I want to apply a filter to eliminate noise and interference. Okay, so there's always noise. We talked about that yesterday. There's always some kind of a static in the background. That's why you have a squelch to adjust it, to just cut that off so anything stronger than that is heard. But now we also have some form of interference, so there's probably another signal nearby. And so that other signal is up here. However, it's dipping down into this space. That's why it's interference. If it was outside of this space, it's not interfering. But it's not interfering by very much, so I can apply a filter. And so what kind of filter do we apply? Well, 500 hertz would be really tiny. That would be like only listening to this amount in here. You would lose a ton of signal. You wouldn't hardly hear it at all because you're missing everything else that's outside of this filter. 1,000 hertz. Okay, that's better. That's doubled that, but still quite small because we have a 3,000 hertz, right? Which is 3 kilohertz, is 3,000 hertz. So we have a 3,000 hertz signal. If we go to 5,000 hertz, well, 5,000 is bigger than 3,000. And so we would actually open our receiver up even wider than the signal and pick up more of this interference. So that can't be right either. So what would we apply? 2,400 hertz, 2.4 kilohertz. That would cut off just the very top and just the very bottom. And it would give us all this in between, which would be a good signal. Yes, it will reduce it a little bit, but we still get the vast majority of it. And so that's how you determine that. So on your test, if you get other questions, what they're really wanting you to understand is how filtering works. And also, you're going to need to know how wide is a single sideband transmission. Because if you don't know that, then those answers don't really apply very well. But if you know, oh, this is 3,000, and that's going to cut it way too small, that cuts it still really too small, that's way bigger, that's not even a filter, that opens up more. Oh, that one is the closest one. Yes.
Why is this be 3,000?
It's 3,000 because that's what they determined would be the best compromise for audio quality and conservation of bandwidth. So single sideband can be more, single sideband could be less, but they picked 3,000 because that sounds good enough that it's comfortable to listen to, but it doesn't take up too much space. If you had a 5,000 hertz single sideband, it would sound even better, but yet you'd just eat up too much space. And when you have a nice radio, I showed one, had it up on the screen earlier. I'll include information, have Michelle include it for the online people. A very nice HF radio that's very affordable, relatively speaking. It has all kinds of digital filtering in it. And so when you're listening to a signal and another station moves in very, very close, it allows you to dynamically adjust. You don't just have these filters set there. If you want a filter that's 2,300 hertz, you can create it. You just dial it in and it builds it for you all within the computer software. And it doesn't use a computer. I'm talking about its internal microcomputer. It's quite an amazing piece of technology. And even in addition to that, as I showed that waveform and we cut off equally at the top and bottom when we made that 2,400 hertz wide, you could actually, instead of just doing that, which is the traditional way, You could still leave it 2400 hertz, but you could slide it down. And so you cut off only the top and you retain everything at the bottom, which could help preserve audio quality. It really is amazing. It's something not possible with old technology. So the new stuff is really cool. Where may single sideband phone be used in the amateur bands above 50 megahertz? And the answer is in at least some portion of all these bands. And so that means any band above 50 megahertz has a section in it that you can use single sideband. That's what they want you to know. Could you use single sideband with your technician class license in those VHF and UHF frequencies? Yes, on any band. Not necessarily everywhere, but at least some place in every band. Which of the following controls could be used if voice pitch of a single sideband signal seems too high or too low? The answer is the RIT or clarifier. RIT is receive increment tuner. And basically when you listen to single sideband, it kind of sounds like Donald Duck. Because remember that the audio is really pinched, it's very small. And so it has some unique voice characteristics. However, when tuned in well, it does sound good. But if there's some frequency drift or some slight misalignment between your radio and theirs, it can have a high or low pitch. And so that RIT or clarifier button knob allows you to make that small adjustment to improve the audio quality. The audio quality will change also as you change the frequency, but if you change the frequency, then you change it on their end too. This allows you to stay on that frequency, but adjust the audio for your liking. What does the term RIT mean? Receive incremental tuning. What is the name of the circuit that generates a signal at a specified frequency? And the answer is an oscillator. Which of the following types of emission has the narrowest bandwidth? Anybody? What's that? No, CW, Morse code, yep. Because all you're hearing is a dot or a dash. You know, it's not about voice quality. I mean, it's very, very small. What is the approximate maximum bandwidth required to transmit a CW signal? So what was single sideband? 3000 hertz or 3 kilohertz. It takes 150 hertz compared to 3000 hertz. So you can see how much smaller that is. So is it 20 times smaller? So in theory, you could have 20 Morse code conversations happening simultaneously in the exact same amount of space to have one voice single sideband conversation. Which of the following is an appropriate receive filter bandwidth for minimizing noise and interference for CW reception? Okay, anybody? We should be able to deduce that. 500 hertz, okay? Why is it 500? Shouldn't it be something smaller since CW only requires 150? Well, yeah, it's not an option. And ultimately, that interference may not be from a CW signal. It could be another type of signal. And so we just need to narrow it up enough to eliminate that other type of signal. What is the advantage of having multiple receive bandwidth choices on a multi-mode transceiver? The answer is it permits noise or interference reduction by selecting a bandwidth matching the mode. So what this is talking about is on your radio, especially any modern radio, these are HF radios that have CW and sideband in them. I'm not talking about your Bofang handheld on FM. This allows you to select the bandwidth. You probably don't want to listen to a Morse code transmission with the 3 kilohertz bandwidth because, as we talked about, you could fit 20 Morse code conversations in there. And if you have a 3 kilohertz bandwidth on your radio and you're listening to that Morse code conversation, you could potentially hear 20 conversations simultaneously. It would sound like a bunch of noise. You'd want to select a very narrow bandwidth to be able to hear the one conversation that you're trying to listen to. And so that's what they're talking about. That's what the advantage is so that you could reduce noise and interference. What term describes the ability of a receiver to detect the presence of a signal? That's sensitivity. Okay. How sensitive is your radio? Well, mine's more sensitive than yours because I can pick up a signal that you can't. That's what it's talking about. Which of the following is used to convert a radio signal from one frequency to another? The answer is mixer. Which term describes the ability of a receiver to discriminate between multiple signals? Now we're receiving the signal. This is not sensitivity. Sensitivity means how strong or weak of a signal can I pick up. This is how can I pick from one signal compared to another, and that's selectivity. Think of it as my radio is able to select the one signal I want to hear and not the other that I don't want to hear. What is the function of automatic gain control, or AGC? And it keeps the received audio relatively constant. And so the way that these work, so AM means amplitude modulation. Single sideband is a type of AM, right? Except we've eliminated the carrier and one of the sidebands. And when you've seen AM or single sideband, if you speak loudly into your microphone, the signal actually gets louder on the other end, as opposed to an FM signal, which is constant. And so your AGC is going to try to average the peaks and keep it as a steady, constant signal. Otherwise, as that strength of the signal, or as the person speaks more loudly from one time to the next, you might find yourself listening real close and then blowing yourself away as it comes in. In fact, you will hear that very weak signals sound very quiet and you have to turn the volume up, and very strong signals are quite a bit louder.
So how does that apply to AM and FM regular commercial radio?
Well, so on an AM station, they will have systems, it's called compression, where they try to keep the volume that's fed into the transceiver at a steady rate and always high, because the amount of power that it puts out varies based on the amplitude that's being fed into it, so the volume of your voice, and they want that thing to be as strong as possible so they can reach the maximum area. On FM, the signal strength does not vary at all, and in fact, if you scream into your microphone, you will simply just start causing distortion of the audio, but not ever will you be able to increase like the strength of the signal. So you get a lot of people who are used to be CB radio operators, and they'll scream into their microphone because that literally did make them louder to the other end. And then they get into ham radio and get on a repeater and they're screaming and carrying on, and they just sound like mess because they're just overdriving the radio and not actually increasing the power.
Question, can you use a dual trace
To listen? Okay. So the question was, can you use a dual trace oscilloscope to listen to a band? Well, not to listen, because it's not a receiver. But yes, you could absolutely be able to actually view that waveform as the person is talking. It would look something like that. And you'll see that vary as they're speaking. And it's a very commonly used piece of test equipment, especially on the audio chain part of the transmitter. So as you're feeding the audio in, it is a good way to help you tune the audio to make sure that you're not overdriving the radio and that you have enough microphone gain to properly drive the radio. So you want to drive it as hard as you can to its limit, not to exceed it. Where is an RF preamplifier installed? Okay, we talked about an RF amplifier a couple times. So what is an amplifier? It takes a small signal and amplifies it, right? Everyone understands what an amplifier is. An RF amplifier takes a RF signal, a radio signal, and amplifies it. But this is an RF preamplifier. Okay? A preamplifier increases the signal, but not your transmit signal. It increases the signal that you receive. This is a receive amplifier. So where would it be installed? Between the antenna and the receiver. What device converts the RF input and output of a transceiver to another band? Okay, so what's happening here? We have an RF, a radio signal, and we're going from one band to another band. Okay, well, what do you call a person who goes from one gender to another gender? Okay. All right, we will not forget that. If that is on your test and you fail, just go home. You failed me if you fail that. Okay, you will remember that, I promise. Okay, which of the following best describes DMR, digital mobile radio? It's a technique for time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel. If you remember, on the first day, I talked about DMR and talked about how it can hold two simultaneous conversations because it has a time slot 1 and a time slot 2. And depending on which time slot you are in, it will sit there and drop your digitized audio in that time slot. And then in the very next time slot, it will drop the other person's, and it keeps alternating and allows two simultaneous conversations to happen. And so that's what it's describing here. So hopefully you will remember that. I'm sorry? Correct. So what it is it's pointing out that it's 12.5 kilohertz. It's very narrow because, yeah, and what did I say that FM was? 25. Now remember, their answer was that 10 to 15 wide, but it's 25. This does it on 12.5, so it's half of the voice bandwidth required for an FM signal. And then in that half, it's actually able to carry two signals. So it's 4 times more efficient. What is a talk group on a DMR digital repeater? And a talk group is a way for groups of users to share a channel at different times without being heard by other users on the channel. Okay, I know that's complicated. It's actually very simple. What a talk group is because it's all digital, so it's controlled through a computer. We have a different talk group. We could have a talk group for Milford, Ohio. We can have a talk group for Richmond, Indiana, and a talk group for Los Angeles, California. And the people who want to participate in whichever group, join that group, and their conversations are confined within that group. We can all be using a set of repeaters. We still have to take our turns unless we're in different time slots. Remember, because time slot 1 and time slot 2 can talk simultaneously. But it basically says, oh, if they're in a talk group that I'm not part of, I don't even want to hear their conversation. And you don't. So it's just a way to group people, however you choose to group them, by location, by interest, by whatever, and it makes sure that their communications stay within that group.
So what's the official definition of channel?
Well, a channel is a frequency. Yep.
Like 250,390.
Yep. You pick the frequency, and that's a channel. Yep. Yep. I mean, if you think about it like CB radio, CBs have 40 channels. Well, those channels represent a frequency. Each one is a unique frequency.
What bandwidth and do they? Well, they've got to account for before the next channel.
Yeah, so the question is, do they account for the bandwidth between channels? Absolutely. Yeah. But for the purpose of this, what is a channel? We're not talking about multiple channels or how they could interact. A channel is a frequency, and it would be up to whoever's designing these channels to ensure that they're properly spaced so that they don't have interference. But that's why they don't care. It's frequency independent. You could operate this on any band that you wanted, maybe. So that's why they don't care about the frequency. They just want you to know that it's on a channel, which is, a theoretical frequency, no matter which one it is. How can you join a digital repeaters talk group? You program your radio with the group IDs or code. Okay, so different talk groups have different IDs or codes, and you program that into your radio. So if you want to talk on the Los Angeles talk group, you look it up in the list, get its ID, program that into your radio, and now you can participate in it. It's not any more complicated than that. And it probably doesn't make a lot of sense until you get a radio that can do this and then you actually do it. But they just want you to understand there's a process.
So what are you actually doing? You're programming the frequency for a certain time.
No, you would. So what this would look like is you would find a DMR repeater in your area. Then you would look up the group ID for whichever group you wanted to talk in and program that into your radio. And then when you transmit it into the repeater would receive that digital data, because it's digital radio, and say, oh, you want to talk on this talk group? And it would put that voice into that talk group and send it over the internet to all the other repeaters that are participating. Yeah, in a way, you imagine there's a server on the internet. The question was, is that kind of the way it works with Zoom? And yes, so Zoom as the company has like a server or really multiple servers, but anyways, they act as kind of one giant cloud, right? But yet there are tens of thousands of Zoom meetings probably all happening simultaneously, yet they're kept separated because they have different invite codes. And so they're all happening at the same time. They don't have any interaction with each other, and you could choose to join any one that you would have the invite code for. Yep.
And more than one group use the same repeater?
If it's a DMR repeater, yes, because you could operate in time slot 1 or time slot 2. And then, of course, you could ultimately just share where when somebody else is transmitting, you can't, but between their transmissions, you could transmit. So that would allow you to share, but it's generally doesn't work very well that way, unless you're all in the same group together. Then you're taking turns.
So you can only have 2 groups per repeater.
Yes. Yep. Which is why if you don't need to use the repeater and could talk to somebody directly, you should switch off to a simplex frequency to free it up for the people who do need to use it. Which of the following best describes broadband Hamnet as referred to as high-speed multimedia network? And it's an amateur radio-based data network using commercial Wi-Fi gear with modified firmware. If you see high-speed multimedia network, HSMM is what that stands for. HSMM uses modified commercial gear for data networking. That's what you need to know.
What question was that? The last one. T8, D12.
What might be a problem if you receive a report that your audio signal through the repeater is distorted or unintelligible? The answer is D, all the above. So you're either slightly off frequency, your batteries are running low, or you're in a bad location. What might happen if a transmitter is operated with the microphone gain set too high? So you're screaming into that microphone. The answer is the output signal might become distorted. What can you do if you're told your FM handheld or mobile transceiver is over deviating? Okay, so over deviation is where your audio is getting clipped. So you would have, here is the width of the amount of voice bandwidth you have. If you, it should look something like that. If you're talking, screaming into your microphone, it will look something like that, where it's getting cut off here. It's just lost because you only can operate within that parameter, but yet you are choosing to scream into your microphone. And so the audio that gets just too loud just gets clipped, and so you're over deviating. Your deviation is how much from top to bottom you're going. So what can you do? Well, talk louder. No, that's the problem. Let the transceiver cool off. That has nothing to do with it. Change to a higher power level. Nothing to do with, oh, back off of that microphone that you're screaming into. Yes. Yes. Yeah. Maybe it's possible that your radio is adjusted such that your voice is so booming and you're the, you're a ham radio operator, but you're also the local DJ at night and you can't help it. Yeah. What might be the problem if a repeater user says that your transmissions are breaking upon voice peaks? That's this. You're talking too loudly. Which of the following would reduce ignition interference to a receiver? So they're talking about you're driving in your car, so it's a mobile or a handheld radio, and you've got noise from the ignition system in your car. Turn on the noise blanker. So your radio will have a feature called noise blanker, and it will potentially help. I'm glad they put minimize because sometimes it doesn't fully eliminate it. Which of the following could be used to remove power line noise or ignition noise? Okay, it's called the noise blanker. Well, squelch eliminates the background noise and says, I don't want to hear a signal unless it's stronger than the background noise. Noise blanker is there is some form of external interference, like from power lines or the ignition system in your car, and it says, I want to eliminate that. Oftentimes, your ignition noise will not break your squelch, but when you're receiving a signal, you'll hear it in the background, and it'll be really annoying, and you'll hit your noise blanker, and hopefully it just vanishes, filters it out.
Does that have to do with where it's, how it's?
Yes, it's basically the spark from your ignition system is getting picked up through the antenna and coming into your radio. You're picking that up. Yep. What is the source of a high-pitched whine that varies with engine speed and a mobile transceiver's receive audio? That's the alternator. So your alternator is making noise. Yep. It can be eliminated with DC filter chokes. Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? It's a ferrite choke. Okay. I don't see. Oftentimes on like laptop power cords, you'll see, you know, the little round plug that you plug into the laptop, and then it has a little black barrel looking thing. Yep. Right there on the end of that cable. That is a ferrite choke. And what that does is it stops signals from coming onto the outside of the cable from the air and traveling into the device. So that's what keeps their microphone from getting buzzes. And if that wasn't there, there would very likely be a constant buzz from, especially from fluorescent lights above. That's what eliminates that. Because the choke is a metal ferrite core and it blocks it. It's just a characteristic of it. What should be the first step to resolve cable TV interference from your ham radio transmission? Be sure all TV coax connectors are installed properly. Okay, and the reason for that is if the connector was put on, but maybe the shielding has pulled away and isn't fully covering the cable, you can get interference in there. So, which of the following can cause radio frequency interference? The answer is all of the above. Okay, fundamental overload is that you have a very strong signal. So if you listen to AM radio, but you live 5 miles outside WLW in Cincinnati, you probably can't listen to WLW. It's so powerful, it just blows away your radio. Your radio is overwhelmed by the strength of the signal. It's just the way it works.
So around VOA Park,
Yeah, you'd have a lot of problems there. Harmonics. So a harmonic is if somebody is transmitting on a frequency that is half of your frequency, their radio will have a harmonic that doubles into yours. Okay, so if you're transmitting on 10 megahertz, I could probably also hear you on 20 megahertz. It will be much weaker, and you're not actually transmitting there because you are actually on 10, but because of something called a harmonic, I can actually hear your signal there, so it can cause interference, even though there's no actual transmitter there. Spurious emissions. Spurious emissions are when you have your voice signal, there are always little spurs, so the signal looks something like okay, our primary signal is in here, and here are the spurs on my signal. They're obviously much weaker than the signal that's up here. They're clear down here. They're little spurs. If my radio is designed very well, these spurs are quite low and do not cause interference to anybody. But if the radio is cheap and designed minimally, sometimes these spurs can be quite large. And they're causing interference outside of the frequency that you are intending to transmit on. What is a symptom of RF feedback in a transmitter or transceiver? And it's reports of garbled or distorted or unintelligible voice transmissions. Okay? So it's basically that RF, the radio wave, is getting between your antenna system and your microphone. So your radio signal is being induced onto your microphone cable, and then that's messing up the audio. Which of the following is a common reason to use shielded wire? To prevent coupling of unwanted signals to or from the wire. If you put a wire up in the air, it will start picking up radio signals. Now, there's not necessarily a radio connected to it to do anything with it, but it will pick up radio signals. If that wire is connected to your microphone, which of course it is because your microphone has a wire, it can pick up radio signals. How would you fix that? With one of those ferrite chokes. But that's why you would want to use shielded wire. So that shielded wire covers the internal wires that carry your actual voice, and then that shield goes to ground. And so that any signal that gets picked up just gets sent straight to ground and gets nullified out. But if you use unshielded wire, then you're using an antenna and it will pick up noise and interference. Which of the following actions should you take if a neighbor tells you that your station's transmission are interfering with their radio or TV reception? Make sure that your radio station is functioning properly and that it does not cause interference to your own radio or television when it's tuned to the same channel. So it is very important that your radio is operating correctly. I'm looking for what FCC Part 15 says. I can't find it very quickly. Every consumer device that you buy that has a receiver or a transmitter in it, including your car stereo as a receiver. You know, if you have a wireless presentation clicker, it's a receiver. These are Part 15 certified devices, and it basically says this device may not cause harmful interference to any other device. That's why you're allowed to operate it without a license, because you have to operate it in a way that doesn't cause interference to anything. It also says this device must accept harmful interference from any other device. So the fact that your neighbor's Part 15 television or radio is getting interfered with by your Part 97 ham radio, you could just tell your neighbor, too bad, so sad, read Part 15. You should make sure your station is not operating outside of its parameters, and it would be neighborly to help them eliminate that problem, maybe by installing some of those ferrite chokes. But ultimately, too bad, so sad. you are allowed to interfere with their setup, and their setup is required to accept that interference. So you have a lot of power.
It sounds like C is the right answer when you say that. For the test, I mean.
Yeah, well, as is
We're
it.
all gonna remember two bad subsets.
Yeah, well, yeah. Do make sure your stuff is operating correctly first. What would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? The answer is the receiver is unable to reject strong signals outside the AM or FM band. So this is a AM or FM radio, like in your car. And that is not ham radio, obviously, that's broadcast radio, but yet it's picking up a ham radio signal. Why? The ham radio signal is so strong and their radio has such poor selectivity that it's picking up a signal outside of its normal range. It's unable to reject it and only pick up what it's supposed to. Which of the following is a way to reduce or eliminate interference from an amateur transmitter to a nearby telephone? Put an RF filter on the telephone. In fact, you can buy telephone cords that already have those RF chokes installed on them. And if you have DSL internet service, which a lot of people don't have anymore, but if you do, they give you telephone lines, cords with that already installed. How can overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? And it's block the amateur signal with a filter at the antenna input of the affected receiver. So this isn't at your house, this is at your neighbor's house whose non-amateur radio, whatever kind of radio it is, you put a filter at their antenna to stop the frequencies from your ham radio getting in. Remember, your ham radio is just, it's so strong, their equipment is so poor that it can't reject the ham radio signal. So you put a filter in there, a circuit tuned to the specific frequency so it blocks that, but it still allows whatever they're normally trying to listen to. Which of the following can reduce overload to a VHF transceiver from a nearby FM broadcast station? A band reject filter, which is the type of filter that you would use in the previous question. It just the previous one described where you install it. This one is just describing what that filter is. So if they're listening in the FM broadcast band and your 2-meter band radio is interfering with it, you would install a 2-meter band reject filter. So it rejects 2 meters, but still listens to FM broadcast.
Are harmonics included in that?
Absolutely. Yep. Well, so the question was, there's been a lot of questions about what do you do with interference, and is the answer always some kind of filter? The only exception would be was to make sure that that cable TV connector was installed. Other than that, it would always be a filter. That was reducing interference. Yeah, and it's not interference from your radio, it's interference from like another signal. Yeah. What is a Part 15 device? And it's an unlicensed device that may emit low-powered radio signals on frequencies used by a licensed service. Okay, so that's the consumer. So as a consumer, you get a low-powered device, and you don't have to have a license. No, because CB radio has its own radio service, the Citizens Band. This would be, again, like this is wirelessly communicating to my laptop to change the slides. So it's got a transmitter. It's very low powered. I don't require a license to operate this. It's a consumer device. Cordless phone, absolutely. Yeah, part 15. Garage door opener, part 15. Yep, those are all part 15 devices. Anything with a transmitter that doesn't require a license. I know CB doesn't require a license either, but it used to back in the day. And it is a specific radio service. Like those family radio service radios, FRS, you can get at Walmart for like $20, like kids walkie-talkies nowadays. Those are in their own radio service and they're unlicensed, but they're not low power devices either. They can talk about a mile away, or some of them lie and tell you they'll talk 30 miles away. But that clearly shows you that they're not that low power device. So that's why they're not part 15. What should you do if something in your neighbor's home is causing harmful interference to your amateur station? All the above. Work with your neighbor to identify the offending device. Politely inform your neighbor about the rules that prohibit the use of devices that cause interference. And check your station and make sure it meets the standards of good amateur practice. There have been a number of illegal grow operations discovered because people have gotten cheap Chinese grow lights and have marijuana farms in their basements. And those grow lights, because they're cheap Chinese, not meeting US standards, are emitting a lot of spurious emissions. And they've interfered with people's ham radio. And what do ham radio guys like to do when they see interference? Track it down. And then they go and tell the people, and then the people don't respond. And so then they call the law because it's illegal to interfere with ham radio. And then the law investigates and finds there's an illegal grow operation. So that has happened more than once. And that's what the ham radio guy looked like that found that illegal grow operation. What is the electrical term for the electromotive force, EMF, that causes electron flow? Voltage. This is just something to remember. What is the unit of electromotive force? So we're talking about voltage, right? We already talked about the electromotive. So we're talking about voltage. What is the unit? It's the volt.
Is it Chevy?
Which instrument would you use to measure electrical potential or electromotive force? So if we're measuring voltage and the unit of a volt.
I want to get that one in.
Go ahead.
Voltmeter.
Voltmeter. What is the correct way to connect a voltmeter to a circuit? You connect a voltmeter to a circuit in parallel. Okay? The way that works, you have to understand. So here's my crude drawing of a 9-volt battery, right? Here's the 9-volt. And it is connected to this light bulb here with wires. I want my voltmeter here. And I connect the wire here and the wire here. This is in parallel. I haven't broken these connections. Okay? So I'm in parallel with that. If I don't want to have to draw this twice. If I take the wire that was here, I take it off, and I'm going to connect it here and here. This is in series. That means that the electricity has to flow through my meter to get to that light. But where before, it went to the light and to my meter. But here, it has to flow through it. This is series. So parallel is how I measure voltage. Which of the following battery types is rechargeable? Answer is all the above. Which of the following battery types is not rechargeable? And it's carbon, zinc. How much voltage does a mobile transceiver typically require? $12. Yep, you got a 12-volt battery in your car. Where should the negative return connection of a mobile transceiver's power cable be connected? The answer is at the battery or the engine block ground. What is the name for the flow of electrons in an electric circuit? The answer is current. Yep. You could think of these things like you would with water. Okay? The flow of water is the current, and the pressure of the water is the voltage.
Go against the current, it's called shock.
Well, you can also imagine that if you have a wire or a pipe and you have water flowing through it, but you increase the pressure too much, what happens? The pipe bursts or the wire breaks. So that's why wires can burn up, because they had too much, a combination of voltage and current flow through them. Which instrument is used to measure electric current? Electric current. It's the ammeter, because current is measured in amps, voltage is measured in volts. So we have a voltmeter that measures volts and an ammeter that measures amps. How is a simple ammeter connected to a circuit? In series. Electrical current is measured in which of the following units? Amps or amperes. Which of the following is a good electrical conductor? Copper. Should be obvious. That's one of the freebies. Everyone gets that one right. What is the name for a current that reverses direction on a regular basis? Alternating current. Why should wiring between the power source and radio be heavy gauge wire and kept as short as possible? To avoid the voltage falling below that needed for proper operation. So obviously, if you need just a 10-foot wire, but you install 100 feet of wire, there's going to be voltage drop on that long length of wire. What must be considered to determine the minimum current capacity needed for a transceiver power supply? All the above. So the efficiency of the transmitter at full power, receive and control circuit power, and the power supply regulation and heat dissipation. Which of the following devices or circuits changes an alternating current into a varying direct current signal? Rectifier. This is just something to know. It's an electronic component. What is the name for a current that flows only in one direction? Direct current. DC. What electronic component allows current to flow in only one direction? It's a diode. It's just an electronic component. Is what it does. What are the names of two electrodes of a diode? It's anode and cathode. How is a cathode lead of a semiconductor diode often marked on the package? It's with a stripe to let you know which one is the cathode. Because it's remember, it allows to flow in only one direction. So if you hook it up backwards, it doesn't flow at all. So you need to know which side is which. So why did they pick that side to mark? Because they did. They had to pick something, 50-50 chance. What electrical component opposes the flow of current in a DC circuit? It's a resistor. What instrument is used to measure resistance? An ohm meter. Resistance is measured in ohms. What type of component is often used as a adjustable volume control? It's potentiometer. Potentiometer is essentially just a variable resistor. That's the volume control. What electrical parameter is controlled by a potentiometer? It's a variable resistor, so resistance. Which of the following is a good electrical insulator? Yeah, glass. What type of electrical component stores energy in a magnetic field? It's an inductor. What electrical component is usually constructed as a coil of wire? An inductor. So whenever you see a coil of wire, that is an inductor. What is the ability to store energy in a magnetic field? That is inductance. Okay, we had an inductor, but its ability to store that energy and how much energy it can store is its inductance. That's its measurement of how efficient or the size of that inductor is. What is the basic unit of inductance? I mean, voltage was volts and amps or current is amps. Well, inductance is the Henry. There's probably because somebody who figured this out hundreds of years ago is named Henry. I don't know. What is impedance? What's resistance? Resistance is measured in ohms, but resistance is the opposition of flow of direct current. Impedance is the opposition of flow of an alternating current. Okay, it's the same thing, but for AC as opposed to DC. Remember when I talked about that antenna, that dual band antenna, that coil? Your radio sends a signal here, and if it's on the proper frequency, it hits this coil, which opposes alternating current at a specific frequency based on the size of this coil. And it hits it and stops and says, okay, well, I guess this is all the antenna that I'll use. But then when you send a different frequency of the signal, it just blows right through there and utilizes the whole thing. That's how that works, because this coil is an inductor and it's tuned specifically for what frequency you want it to oppose. Yes, and I'm talking about DC. AC is called inductance, not resistance.
Okay. Resistance chicks, resist Washington DC, do prayer.
See, now I have to show that ohm picture that I showed you. All right.
What is impedance? The measure of opposition of impedance. What is the bit of impedance? So that's resistance.
Does ohms go for AC and DC?
It does, but the opposition of an AC signal is inductance, and the opposition of a DC signal is resistance. They're both measured in ohms.
You pray for both.
Opposition. Okay. Well, let's just. Okay.
What is the unit of impedance? Got it. Nailed it. And so you'll find your ham radio is always going to be 50 ohms impedance. So you need a 50 ohm coax and 50 ohm antenna.
Hey, does the coil in the antenna cause inductance or impedance?
Inductance. What is the ability to store energy in an electric field called? Capacitance. Remember, in a magnetic field, it's called inductance. And in an electric field, it's called capacitance. Just memorize it. Just memorize it. What is the basic unit of capacitance? The caps? No, that's not an answer. It's the farad. Makes as much sense as the Henry. Yeah. What electrical component stores energy in an electric field? Capacitor. What type of electrical component consists of two or more conductive surfaces separated by an insulator? A capacitor. You could build your own capacitor at home. You could take a roll of aluminum foil, tear off a sheet, then take a roll of wax paper, tear off a sheet, lay it on top, and then take another piece of the aluminum foil and put it on top. Now you've got two metal plates separated by an insulator, and you attach wires to that, and you've built a capacitor. It stores energy in a magnetic field. What electrical component is used to connect or disconnect electrical circuits? The switch. The light switch in your wall literally connects and breaks the wires, puts them together and takes them apart. That's all it does.
Okay, so when people have these cell phones, they put them in like a bag, a Faraday bag that has metal. Are we talking about the same concept?
No. So the question was, when people put their cell phone in a Faraday bag or Faraday cage, is that the same thing? No. What that's doing is you're taking your cell phone and you are putting it inside of essentially a metal box that just blocks the signal from going through. When you drive across a bridge, especially a metal covered bridge, like a very large bridge, next time you see one, whenever you see one, tune to an AM radio station and then drive through the bridge, and the AM station will just go bye-bye. Now an FM station will keep on playing. That's because the wavelength of that FM is small enough that it goes through the metal openings that form that bridge's skeleton. But the AM station is an incredibly long wavelength. I don't know exactly, but something like 1,000 meters. And it can't penetrate, even though there's big holes in the bridge that you can see through, in the skeleton of it. It's too big, it can't penetrate through there. So if you're going to build a Faraday cage for your cell phone, which uses sometimes microwave frequencies, you better have a very tight mesh. And in fact, probably the best thing to do would be to build a solid copper box and solder all the edges together, because it's using very small millimeter size wavelengths that can get through small openings. What electrical component is used to protect other circuit components from current overloads? So we're running too much current through a circuit, and I don't want to destroy the circuit or burn up the wire. So what do I do in case that happens? Well, I put in a fuse, because then the fuse gives its life to save the wire or the circuit or whatever's on the other side. Hopefully you fix the problem and then put in a new fuse, and then it operates normally. Well, a GFCI is a circuit breaker, so it's at least resettable. GFCIs don't do it strictly because of current, but it is like a circuit breaker in your house. It's just a resettable fuse. Think of it that way. Which of these components can be used as an electronic switch or amplifier? That's a transistor. So transistors can switch or amplify. What class of electronic component uses a voltage or current signal to control current flow? It's transistors. Have you ever heard of a transistor called a semiconductor? Well, how do you semi-conduct something? Aren't you either conducting it or not conducting it? Well, it's a transistor is a semiconductor because you can control how much it conducts at any given time based on the input that you feed it. Which of the following electronic components can amplify signals? What did I say was an amplifier or a switch? Transistor. What is the term that describes a device's ability to amplify a signal? It's gain. Okay, that's just the measurement. My amplifier has a gain of 10. Well, that means it multiplies the signal by 10. My amplifier has a gain of 100, multiplies the signal by 100. So it's how much gain. Which of the following could be the primary gain producing component in an RF power amplifier? Well, we're talking about an amplifier. What amplifies the transistor? Which of the following components can consist of 3 layers of semiconductor material? No, it's transistor. Triode is there to throw you off. Yep. What does the abbreviation FET stand for? Field effect transistor. It's just a memorization thing. All right, Ohm's law. Which term describes the rate at which electrical energy is used? Power. Yep.